Welcome to Lesson 3-11. Today you'll be solving division problems. Your objective today is to be able to write and solve division word problems. Turn to page 95 of your workbook. Let's take a look at number 1. Consider a division problem, 2 divided by 5. You're going to be asked to describe a situation that this division problem could represent. Then you're going to be asked to draw a diagram to represent the division and then find the solution. Number 1 I will do for you, and then you will do numbers 2 and 3 on your own. Because I'm a pizza lover, I'm going to use pizza to describe my situation. So I'm going to pretend that we have 2 regular pizzas and we need to divide it into 5 equal parts. Or we're going to take 2 regular pizzas and give them equally to 5 different people. So I've written out my scenario. I have 2 regular pizzas and would like to divide them equally amongst 5 of my friends. So now I'm being asked to draw a diagram to represent this division problem. Then I have to find the solution. How much will each of my 5 friends receive after I divided the pizza up? So for my diagram, I've created 2 regular sized pizzas, different colors. And I'm going to take each of those 2 regular pizzas and divide them up into 5 equal parts so that each of my friends can get 1/5 of each pizza. So I'm going to divide into 5 each one of my pizzas so that now each of my friends can get 1/5 of each of the pizzas. So from the red pizza, each of my fellow classmates or friends will receive exactly 1 piece out of the red pizza, which we've determined to be 1/5. And out of the blue pizza, each of my friends will also receive 1/5. They can take 1 piece from each of these pizzas because I've broken each pizza into 5 equal pieces. They're all equal and each person's going to get the same amount from each one. So you can see now that each person is getting a piece from each of my pizzas. They're getting 1/5 plus 1/5. If you add 1/5 plus 1/5, you get 2/5. And this is how much pizza each of my friends are going to get total from both of the pizzas. So from each individual pizza, my friends are only going to get 1 slice because I've cut them into 5 equal pieces. If we only had 1 pizza, that would be the best way to divvy up my pizza amongst 5 people. We have 2 pizzas, so I just divvied up each one individually into 5 equal pieces. I divided them up into 5 equal. So now each of my friends can get 1 piece from each of my pizzas. All of them will get the exact same size. They each get 1/5 from each one. And if you add up both of those fifths, you will get 2/5. We'll check to see if that can be simplified, but it cannot. On number 2 and 3, you will be doing on your own. But for number 2, let's take a look at that problem. Consider the division problem 4 divided by 3. What does that mean? If you have 4 of something and you want to divide it into thirds, then you want to know how many thirds you can get from those 4 objects. So let's go back to the pizza scenario. If you had 4 whole pizzas and each pizza was cut into thirds, or 3 pieces, then how many people could you serve? Or in another scenario, let's say you have 4 pieces of cheese and you only need 1/3 of that piece of cheese to make a sandwich. How many sandwiches could you make if you had 4 slices of cheese and you cut them all into thirds? Or one more likely scenario. Let's say you have 4 yards of fabric and you want to make stuffed animals that take only 1/3 of a yard of fabric. You would want to divide those 4 yards of fabric into thirds to see how many stuffed animals you could make. Come up with your own scenario for number 2 and 3 and complete with a diagram and your final answer. Pause the video now. We're on page 96 of the workbook now. On questions 4 through 11, which are all word problems, you may use diagrams or equations to solve each one. Where possible, you should use diagrams. For example, number 4, you want to run 5 miles around a track that is only a quarter of a mile around. You could create a graphical representation of your track, could label that a quarter mile, and you could likely assume that if you wanted to run 1 mile, how many laps would you need to run? How many quarter miles would it take to get 1 lap? And you could then easily convert that into how many laps you would need to run in order to run 5 miles. You can also create a mathematical equation with this problem because you'd like to run 5 miles and each lap is a quarter mile. You would want to know how many quarter miles are in 5 miles. In other words, you would want to take your 5 miles and divide it into quarter mile laps to see how many total laps you would need to run. So for number 4, you can see there's a diagram that could be drawn as well as an expression to solve this problem. Pause the video and complete number 4 now. Welcome back, and let's take a look at number 5. There is 1/6 of an extra large pizza left over in the fridge. If 3 friends share the pizza equally, what fraction of a whole pizza will each friend get? I've circled my key numbers, I've underlined my question, and now immediately I want to start drawing a picture of my extra large pizza, and I want to break that into 6, 2, 3, 4, 5, which makes 6 pieces. I need to represent that I only have one of those 6 pieces left in the fridge. The rest is gone. It says I only have 1/6 of an extra large pizza left over. So I've represented my 1/6. Now I need to break that up into 3 pieces so that I can divide it up with my friends equally. So I'm going to draw a line inside of this piece to break it up or cut it up into 3 pieces. So 1, 2 lines will cut that into 3 pieces. Now I have drawn my diagram, and in order to see what fraction of the entire pizza that each of my friends is getting, I would need to cut all of my 6 into 3 equal pieces, and I'll leave that for you to do. But another way to do this would be with an expression. Here we're going to be using the word of, which means multiply, but my friends are going to be getting 1/3 of my 1/6. 1/3 of my 1/6. Why? Well, because each of them are going to get 1 piece out of 3 pieces from the one that's left over. So that's 1/3. They're getting 1/3 of the entire 6th that I have. So here we could create a multiplication problem to show what fraction of the entire thing each person will get. They're going to get 1/3, or 1 out of 3, out of the 1/6 that I have. Of course, there's another expression I could use because multiplication and division are related. Of course, I could show this with a division problem. So what am I dividing? Well, I'm dividing 1/6 of the pizza that I have left, 1/6, and I'm dividing that up into how many people? 3 people. So 1/6 divided by 3, or 1/6 divided by 3 over 1, which you can see when we convert this to multiplication, because that's how we do division. We convert it. We do 1/6, the opposite sign, and the reciprocal of 3 over 1, which is 1 over 3. We can see that we have the exact same problem here, but in reverse. And that's okay because multiplication is commutative. Commutative means that you can reverse the numbers and get the same answer. So these problems are identical because we could switch the factors around and not have a problem. And now I'd like you to pause the video and complete number 5. And now let's take a look at number 6. Oscar's aunt lives 50 miles away, or my aunt lives 50 miles away. This is 6 times as far as my grandfather lives. So how far away does my grandfather live? What could you draw to show or demonstrate this word problem? I immediately think of a number line when I'm thinking of distance. If I have a number line, I would be the first one on my number line. This would be my house. And farthest away from me would be my aunt, who is 50 miles away. My grandfather, however, is a lot closer to me than my aunt. He's 6 times closer to me than my aunt is, because my aunt is 6 times farther than my grandfather is. And here we're talking about sixths. So what I need to do probably is break my number line into sixths. We do that with 5 lines. These aren't perfectly equal, but they don't need to be for this demonstration. Now we have 6 equal spots. 1, 2, 3, 4, 5, 6. I'm the first line, that's 0 miles, because I'm 0 miles away from myself. My aunt is the last line because she's farthest away at 50 miles. And now I need to figure out where my grandfather lives. My grandfather lives at the 1/6 mark. And how do I know that? Well, it says that my aunt is 6 times farther than grandfather. So what is 6 times 1/6? That equals 6 over 6, which equals 1. And 6 over 6 is where my aunt lives. She lives at 6 over 6, or 1 whole number line away from me. So my grandfather, who's 1/6 of my aunt, is going to be here at 1/6. Now, if we knew what mile marker 1/6 was for each of these lines, we would have our answer here already. But in order to figure out what mile marker this is, we'll have to figure out what 50 divided by 6 is, because each of these has to be equal. So here we have already said the expression, because there's a couple of ways you could say the expression, but we've just said that if we could just figure out what this mile marker is right here, we would know the answer. And I don't think you can cut 50 miles into 6 equal places easily, and certainly not with whole numbers. So we're going to need to create equations, and we've already said the equation. We're trying to cut 50 miles into 6 equal places. So essentially what we're doing is dividing 50 divided by 6, or into 6 equal places. You could look at it from a multiplication perspective as well. We're trying to find out what 1/6 of 50 is. That 50 would become 50 over 1. And when you multiply these straight across, you'll see again that 50 times 1 is 50, and 1 times 6 is 6. We end up with a fraction, 50 over 6, which is 50 divided by 6. So we have an expression, 2 expressions that we could use. We have 50 divided by 6 here, or 1/6. What is 1/6 of 50 miles? Which eventually will get you back to a division problem. There's no way around doing the division problem here. So now I'd like you to pause the video and complete number 6 with a final answer. Welcome back, and we're taking a look at number 7 now. Number 7 says a banner has a length of 10 feet and an area of 7 square feet. What is the width of the banner? So as I go through this word problem, we have length of 10 feet and an area of 7 square feet. And it wants to know the width of the banner. So what could we draw as a diagram to help us with this? Hopefully you said a banner. A banner has a length and a width and an area, and we know that area equals length times width. We know the length of our banner is 10 feet. We do not know the width, but we know the area equals 7 square feet. We also know that area equals length times width, which this might look strange because the length is 10 and the width we don't know, but the area is 7, which is less than 10, and that's 7 feet squared. But the area less than 10 means that the width has to be a fraction, because if it were a whole number, if we were finding area, length times width, two whole numbers multiplied together would get you a larger number than either of the two factors. So we have an area that's smaller than one of our factors already, therefore we know we're not multiplying another whole number. So we can make sure that our answer is reasonable by knowing that it has to be a fraction, because we know that when we multiply a whole number times a fraction, we're going to get an answer that's less than our whole number. So how do we solve this when we don't know what that is? Well, we're going to use our formula, area equals length times width, and we're going to plug in what we do know. We know the area is 7, we know the length is 10, and we know we're going to multiply the length times the width, but we don't know the width. So we're going to make that W. Now there's a couple ways you could solve this. One way would be to guess what W was and then check your answer. Let's say W was a half. What would be half of 10? Half of 10 would be 5, but our answer is 7, so that wouldn't be correct. But we would want to increase our W from 1/2 to something larger in order to get closer to 7. You could continue to guess and check your answers until you get close enough. But a simpler way would be for you to learn a little bit of algebra right now, and that's what I'm about to show you. One of the things to remember with algebra is that whenever you do something to one side, you must do it to the other side as well in order to keep the problem equal. Right now, we have an equal sign here, which says that 7 is equal to 10 times some number. We don't know what this number is, and that is our goal, to find out what W equals. So if we could somehow find out what W equals, or just somehow get W by itself on this side of the equation, then we would know what our answer is. And there is a way to do that, as I was just saying before, that as long as you do the same thing to both sides of the equation, then the equation is still true. So what we could focus on here is trying to get rid of the 10 on this side of the equation. And we can do that by doing the opposite of what's being done to it now. So what is being done to the 10 on this side of the equation? Well, we're multiplying by 10. We're actually multiplying by W here, but because multiplication is commutative, we know that we could easily turn these around and that wouldn't be a problem. It'd still be the same answer. So we could say that we're multiplying by 10. Well, what is the opposite of multiplying by 10? It's dividing by 10. So if we divide this side by 10, we're essentially canceling this out. When you do the opposite of something, it cancels it out. So that's what we're going to do to get rid of the 10 and have W all by itself. Now when we divide one side by 10, we have to do the same thing to the other. Otherwise, the equation is not true anymore. So we're going to do the same thing to the other by showing a division problem, 7 divided by 10. We can show that with a fraction because fractions are also division problems. So while I've solved this problem for you now, because you can see that W is all by itself over here, and W equals 7 over 10, which is all by itself over here. I've actually solved the problem for you, but in the meantime, you've learned a very important strategy on how to isolate variables. And this comes in really handy when you're dealing with problems like this, where you have an unknown side, but they're giving you the area, or they're giving you the perimeter, and they're asking you for the unknown side. Now let's check this problem and see if we're correct. If the width is 7/10 and the length is 10 feet and the area is 7, then 10 times 7/10 should equal 7. So let's do that problem. 10 times 7/10. We could cancel out our 10s, they become 1 and 1, and then we end up with 7 over 1, which equals 7. So we know that we are correct. Now I'd like you to pause the video and complete the rest of the word problems 8 through 11 on your own.